My name is Malik Williams. I'm from Houston, Texas. I'm a sophomore mechanical engineering major.
I'm Mark Eldridge Jr. from Houston, Texas, sophomore electrical engineering major.
All right, my name is Chase Talton. I'm from Houston, Texas, and my major is mechanical engineering.
Man, I don't know how to do this one.
Which one?
Number 11.
Nah, yeah, I get up on that. I skipped it.
Man, MJ, you know how to do it?
Y'all still working on homework? I stopped that. I got tired of that.
This dude over here ordering shoes, bro.
You gave up.
I gave up hard.
Man.
I got stuck on that problem and I was like,
What you got
Get
to
it.
finesse it, man. I'm telling you.
That's it. How? Don't nobody how to do it.
I mean, Chad does. I don't know about y'all, but
Hey.
I'm gonna see if I can try to finesse.
I do got a check account, fam.
Oh,
We in
say
it.
it. We in it. We in it. We in it. Let's get to work. So after looking at the problem, we discovered that these are all the givens, which is Q, K, R, and L. Q is going to stand for the charge, K is going to be the Coulomb's constant, R is going to be the radius around the ring, and L is going to be the length of the center of the ring. Alright, so first things first, in solving this problem, we got to start off with this equation, which is trying to find R1. And R1 is going to equal to the square root of L1 squared plus R squared. So the givens are L, R, you just plug it in, which is 0.009 meters squared plus 0.09 meters squared, and it's going to equal to 0.0904489 meters. Okay, so now the linear charge density is lambda equals Q over 2 pi r, and the net electric field is the sum over the components along the axis. So now we're looking for E. E is going to equal to K, the integral from 0 to 2 pi, is from lambda r d theta over R1 squared times L1 over R1. That's going to equal to K times L1 over R1 cubed times 2 pi r lambda, which is also going to equal to K times Q times L over R1 to the Q power. So then after that, you're going to plug in your components, which is going to give you this over that times 2.5 times 10 to the negative 6 coulombs times 0.009 meters, which is going to be equal to the answer right here, which is going to be 2.73359 times 10 to the 5 newtons per coulomb.
Okay, for the next question, we're trying to find the electric field at L2, which is 3.9 centimeters or 0.039 meters. So first we got to find R2, which is equal to the square root of L2 squared plus R squared. And we plug in our givens and we get 0.0980867 meters for our R2. So then we find the electric field, which equals to K times Q times L2 over R2 cubed. And we plug in our givens and we get 9.28825 times 10 to the 5th newtons per coulomb.
now we're going to find the electric field when it is 3.5 meters away from the center. What we first have to do is find our R. And to find R, we have to do the square root of the length squared plus the radius squared. When we plug in our 3.5, which is for the length, and our 0.09 for our radius, we get 3.50116 for our distance. When we plug it into the electric field equation and we plug in all our numbers for it, we get 1,832.88 newtons per coulomb. So assuming that the ring is a point charge at the origin and that the distance is 3.5 meters, we're going to apply Coulomb's law to find the electrical field, which the equation would be K times Q over L3 squared. When we plug in all of our numbers for that, we get 1,834.69 newtons per Coulomb.
Hey, check, just send me the answers.
Ooh,
Just find out.
So for part 1, it's 2.73 times 10 to the 5th newtons per coulomb.
Okay.
Got that?
Yeah.
Alright. Part 2 is 9.28 times 10 to the 5th newtons per coulomb.
Okay.
Alright, for the third one, we got 1,832.8 newtons per coulomb. Man, for the fourth one, y'all ready?
Yeah.
Alright, we got 1,834.69 newtons per coulomb.
That's
Got
it.
answers right?
Yeah.
Alright, bet. Ooh, man, that was a hassle.
What? Checking it. Clutch.
Thank you, Chad.